back. So as I told you, uh, obviously the modulation schemes have some effect on the network efficiency or the network performance, because as I said, your higher order may give you better performance in terms of data rate, but obviously more the number of bits, more the number of symbols, you have to also tackle with the interference. So that's one problem also. Noise is obviously an issue, because that is what I said, interference and noise. And when we are going to these higher order symbols, we have to also see that we are using good error correction coding schemes so that our data remains protected. Okay. So one more experiment. You can take your user equipment, that is your mobile phone, away from your, so you have this box, the 5G box, and you have the mobile phone. So they are probably very close to each other, within 2 meters. आप जैसे जैसे उस मोबाइल फोन को दूर लेके जाएंगे, you will see that your speed also reduces, your throughput reduces. So that is an experiment which you will be able to perform. अच्छा, जब तक line of sight है तब तक आपको कोई ना कोई throughput मिलेगा. If you move away 30 meters or 40 meters, आप देखेंगे your throughput has become very much close to zero. मतलब it has now become a non-line of sight. So both the transmitter and the receiver, that is your 5G Mantis wave box and your mobile phone, they are not in range of each other. So that time you will see that. Okay. So one more experiment is this 5G new radio time division slot. So as I told you, I'll just go ahead with this. So basically you will be able to see both these things. When I talk about time division, I said that in same subframe we are having the facility of both downlink and uplink. So this downlink, in this slot you can find there are again some 10 to 12 or 15 bits together. So every slot is reserved for some purpose. For example, the downlink may be used for downlink communication. Downlink क्या है? From the base station to the mobile station. The U means uplink, which are only reserved for uplink communication from the mobile to the base station. And you have S. The S basically denotes the, I think the S is basically a flexible slot. जहाँ पे पहला 10 slots is for downlink. These two are meant for some sort of what to say, reserved for guard band, and the last two are for uplink. ठीक है? I move ahead. So the step is how to configure that is simply set up the 5G private new radio. Then obviously you are ensuring that your G node B or your base station is also configured. You are then stopping your G node B and selecting your time division duplexing mode, like you can do it over here. This is your pattern 1 and pattern 2. So pattern 1 basically denotes TDD. Pattern 1 and 2 is both TDD together. So you will have two parallel slots. Okay. So that is something which you can do. So this is what I was talking about. Pattern 1 and 2, you are having both these two together. So that is also one thing which you can do. Analyzing the 5G new radio in 2x2 MIMO configuration. So beamforming is one, multi-user MIMO is one, massive MIMO is also there. So there are various applications. In fact, whatever we did till now was only for CISO. हम लोगों ने एक ही एंटेना, एक ही सिंगल यूजर एंटेना लिए थे, एक ही रिसीविंग एंटेना लिए थे. In case of MIMO, we are using now 2 transmitting antennas, 2 receiving antennas. अच्छा, what will happen if you are using MIMO instead of CISO? आपका performance would be better. Why? Because you are creating more number of copies. कुछ बोले? हाँ, you are creating more number of copies. So if you are creating more number of copies, obviously at the end of the day your SNR would improve. But obviously you need to see that your MIMO slots or your MIMO transmitting and receiving antennas do not suffer from interference. वो भी चीज़ आपको check करना पड़ेगा, because आपकी complexity बढ़ जाएगा. ठीक है? So these are some of the things which you can look into. Coming to the 5G new radio setup, same thing. You first deploy your code, then you deploy your RAN, and then you choose your MIMO. See, till now whatever we are doing was with CISO. अभी हम लोगों ने MIMO में चले गए. So कुछ changes you can do with the setup which we have. Last two experiments I'll tell in very short. So we are not going to talk about device to device communication. Please remember that whenever I am talking about two devices getting connected, जब दोनों डिवाइस आपस में कम्युनिकेट कर, there is no need of any base station. But base station initially is required for what? For setting up the connection. But once your control signals have been set up, two devices can directly communicate. For example, छोटा सा example, Bluetooth. You have two Bluetooth devices, they can directly communicate among themselves. उनको base station की जरूरत नहीं. Simple example of some two devices. So here what we have done is that we are using the same set of requirements. I'm not repeating them. So this is how it looks like. As I told you, this is the transmitter, this is the receiver, or you can use this as the transmitter, you can use this as the receiver. अब देखिए, if this is my transmitter, I am using 448 antennas. If I am using this as the receiver, I am using 448 antennas. So this can directly communicate with this using the 5G box, obviously, because that's a base station, setting up the communication. But once your communication has been set up, these two devices can directly communicate. So this forms your transmitter dashboard, this forms your receiver dashboard. अगर आप इसको transmitter मानते हो, this would be treated as a transmitter dashboard. If you treat this as a receiver, this would be your receiver dashboard. Clear? Simple. So obviously, to do this, there are certain things I would like to tell you. So we are basically analyzing this data. Now, how would you say कि your performance has improved, or how would you say good communication is taking place? We are using some sort of diagrams. The most important diagram is eye diagram. I think most of you know what intersymbol interference is. Eye का मतलब क्या? It's your eyes. तो आंखें जितना बड़ा होगा इसका मतलब क्या है? Noise उतना ही कम रहेगा. Eye जितना कम हो जाएगा, बंद रहेगा, इसका मतलब क्या है? It is fill up of noise and interference. So this is practically your eye diagram. I think we have an eye diagram somewhere. So this is basically your eye diagram. देखिए, the eyes are open. मतलब transmission is taking place nicely, reception is taking place nicely. But अगर ये चीज पूरा distorted हो जाता है, इसका मतलब क्या है? कि here it is filled up with noise or interference. So that's why you're not. So these are some of the basic analysis which we can use. Coming back, the other sort of scheme which you can use is a waterfall diagram. This is also very important. एक blue screen आपको दिखेगा. So basically this waterfall diagram analyzes the signal strength at each frequency. So if your color of that waveform is blue, it is for weak signals. If it is red, it means you are sending strong signals. Okay, and so coming to that, so first and foremost, how do we set up this D2D communication using Wi-Fi? First, we launch this Mantis D2D communication using this GUI. This is a graphic user interface. Then we select, see, this is the sender, so we are selecting the transmitter first. Then we are selecting the sampling rate, the frequency. If you see the signal over here, what is the band? I think it is 178 is the channel number. 5890 is 5.89 gigahertz, which is the FR1 band, and you have 11p. What is this 11p? IEEE 802.11p, which is a protocol which is used for, basically used for, I think, vehicular communication. V2I, V2P, V2V. So vehicular communication is, अगर मैं बोलता दो vehicle आपस में communicate कर रहे हैं, isn't it very similar to saying two devices communicating with themselves? So the protocol used is IEEE 802.11p. You have a message source. या तो आप predefined message add कर सकते हो, something you can add in the command prompt. My name is this, something like this, or whatever. Or you can add a text file over here. उस text file में आप अपना message add कर सकते हो. And so this is your transmitting gain. So as I said you, the maximum gain is 80 dB, but you are normalizing that 80 dB to 0 to 1. तो जितना maximum आप कितना gain तक जा सकते हो? 80, so 80 is normalized to 1. अगर हमने यहाँ पे 65 लिए dBm, that is normalized to probably something like a 0.81 or 8. Okay. You are using the packet data unit. अच्छा, packet data unit is 60 का मतलब क्या है? You are using 20 characters. So 20 characters is your message length. We have chosen 60. What does this mean? That I have chosen 3 words. Say for example, my name is Ranjay. So if the total character comes to 20, it will come 3 times, yes or no. And the character includes space also. So when I write my MI space NAME space is, it covers the entire data word length. So maybe I do not know what, my name is Ranjay kitna bada hoga, but if I say that the total length is 20, it means if I choose this to 60, iska matlab kya hai? That data would be repeated 3 times. Is it clear? Then you are keeping an interval. Interval matlab you are keeping some sort of guard band between these information. Okay. And then finally you can choose your modulation scheme. So you have BPS ke 1/2, ये 1/2, 3/4 का मतलब क्या? 1/2 मतलब क्या? Code rate. Very good. Code rate is what? K by n. K is the number of messages you are sending and n is the total number of messages. For example, in communication, to protect our data from interference, we usually choose a code rate. Code rate half matlab you are sending total 2 bits, out of which 1 bit is used for message, remaining 1 is a redundant bit. So that is what has been chosen. So if I choose 3/4, it means 4 bits. Out of that 3 bits are used for message, 1 is used as a redundant bit. Total length आपका 4 है, but 3 is used for message. ये extra 1 bit, why are we adding? Obviously to make our data protected from any sort of interference which might encounter due to your channel interferences later on. Yes or no? Or some sort of other interferences, I'm not going into that. So this is what we are choosing. I think this is what I was talking about. IM D2D transmitter is probably a total length of 20 characters, so ये 3 बार repeat होगा. Okay. So this is what your modulation and scheme. Parallelly, you have to also choose your receiver also. Receiver में you have to set your password, the same what you have done for your transmitter. What are these? This is a constellation diagram. What do you know from your constellation diagram? देखो, this is for, I think for BPSK, the QPSK. This is for QPSK. So these symbols are very close to each other. इसका मतलब क्या है? There is less distortion. If these symbols would have been scattered over here, what does that mean? Interference or noise has crept into the system. This is the waterfall diagram. What did we say? कि blue का मतलब क्या है? Weak signal है. जैसे यहाँ पे red दिखेगा, इसका मतलब क्या है? Some strong signals. Clear or not? And obviously you can choose your own channel estimation. So here are the channel estimations at the receiver side. Sampling rate is the same. अच्छा, whatever you have chosen at the transmitter, the same you have to choose at the receiver. Sampling rate, frequency would be the same. What you can change is your receiving gain. That is up to you. You can increase your receiving gain. And you can also select your channel estimation. Why is channel estimation very important? If you want your symbols to be detected perfectly, you have to choose your perfect channel estimation. So in this case, we have many such: LS, least square, LMS, linear code, etc. and etc. That also you can select. And finally, we set our PDU length, which is the packet data length unit. The receiver should give you this IM D2C. We are getting IM D2D transmitter, IM D2D transmitter, IM D2D transmitter. So you would get something like that. And these are your receiver diagrams, which shows that whatever you have sent, you are receiving it perfectly. Okay. Even though your transmitter and receiver are very close to each other, probably 2-3 meter भी नहीं. जो मैंने दिखाया था, I think not within कुछ centimeter apart, I think. So you can choose your devices accordingly. The last is setting up a 5G new radio connection using modem. So we are actually now using same connection. इसका पहला experiment क्या था? We are using a 5G connection. We are communicating between a transmitter and receiver using a Wi-Fi band. Here we are communicating between a transmitter and a receiver using 5G new radio band. That's the difference. So these are the user, maybe the user names. So user के जो जितने भी, say for example, as I told you, आपके user equipments के बहुत सारे choices हो सकते हैं. For example, RM500QGL, RM500UCN, RM502QE. So these are the user equipments which are available with us at this moment. According to our requirement, you can choose any one of them. But I think the one which we are using is RM500QGL in our lab. Okay. So obviously these are all having advanced technologies. So first we are launching the 5G modem user equipment, because now we are connecting the transmitter and the receiver using the new radio frequency. So to do that, we are first launching this. Then what we are doing is that we are launching this 5G new radio user equipment. So in the dashboard, we are now saying that these devices can directly communicate using this band. So once you select this, you can enter your input. So these are the protocols, 80, 80R1, 80, these are all the protocols which can be used for communication. But these are basically some commands. If you click onto these commands, these commands will help you in setting up a communication between your transmitter and the receiver. That is what we are doing here also. So moving ahead, once that gets connected, once you are setting up all these things, so we will be able to see the devices which have got connected. So यहाँ पे आपका transmitter and receiver दोनों ही आ जाएगा. Is it very clear to all of you? So finally, some of the smart use cases are smart cities, emergency responses, industrial IoT, and consumer electronics. If I talk about the smart cities, we say mostly the smart cities are using 5G radio bands for communication. It is true, but it's still in in the testing phase in India. Talking about the emergency responses, especially in disaster scenarios, your drones actually play a major role. So the drone which we are going to show you at this moment, I'll just tell you what are they. Most of you who have taken this course on drone technology, I think, have used this. But for the others who have not yet seen this, I'll just give you a small demo, and then you can go outside and use this drone. And obviously, it has a few major applications in consumer electronics where you actually require it for gaming, require it for high bandwidth applications. So overall summary, if I may put it, takeaways as Sir points out, hands-on experience, which you will probably be doing on Thursday. We've understood some of the 5G network, new radio network connections using modem. We've explored what a core and what a RAN is all about. You will be able to set up a D2D communication using Wi-Fi. You will also be able to do a setup of D2D using 5G new radio. And these are some of the things which you can shift and change. So overall, your analysis would be much easier. I thank all of you for listening. So thank you. Thanks to my students who have helped me in preparing the slide. Ardija, thank you. So now I just thank all my, I think, Alage sir, could you just bring on that device? You also have a camera over here. ये जो camera है, ये आपकी आँखें बन जाएंगे अभी. Why do I say it will be your eyes? Because you will now be wearing these goggles. Okay, you will be wearing these goggles. This camera will now be your eyes, and this is your joystick, which is actually a gesture. So if you move it like this, your drone would move towards your right. If you move it towards your left, your drone would be moving towards your left. But you will not be able to see how. आप क्या देखेंगे? आप इसको पहनेंगे तो ये जो है, ये आपके अभी कैमरा बन जाएगा. और ये कैमरा कहाँ पे है? This camera is somewhere over here. हाँ, ये कैमरा आपका यहाँ पे है. Yes. So basically, drone is flying. It can capture a lot of video images. You can use this video image for probably later on analysis. But now what you are going to see is that कि ये जो जब ये कैमरा से images लिया जा रहा है या video लिया जा रहा है, वो आप ये goggles पहन के देख पाएंगे. So your eyes is basically now becoming the camera eyes. Is it very clear? तो यही आपको दिखेगा. हमारे पास अभी कितने? How many of you brought? 2? How many are? 2 3 are there ना? So I think 5 का group कर लीजिए. We have 45 minutes or 30 minutes. Let's not waste time. Please take them outside. Okay. You please come outside. Okay. Somebody wearing that?
आगे तुमको जाना है तो उससे तुम और कर सकते हो, डायरेक्शन का देखना है
ये डायरेक्शन भी आगे पीछे
तो पुराना वाला है,
लेफ्ट राइट
मतलब वो डायरेक्शन का
ये डायरेक्शन का लेफ्ट राइट आगे पीछे
बट हाँ आपके प्रैक्टिस के लिए मेन जो कंट्रोल है यू कैन डेवलप विद दिस तो हाई फाइव उसमें तो आप लोग थोड़ा अंदर चलेगा उधर चलेगा
Ang sakit na kanina, kawaya. Ang sarang mga resility na yun.